Thank you, everyone, for joining the presentation today. This is the third webinar in the series of presentations we have had for the MySQL HeatWave. We had the first one on MySQL Autopilot. Then the second one was on the scale-out storage and scalability of HeatWave. And this is the third one on accelerating more workloads with MySQL HeatWave, which has been a very sought-after request from our customers. So I'll start off with a little bit of a background introduction about MySQL HeatWave, and then I'll get into the details of what are the various constructs, new SQL constructs, which we are accelerating in this recent announcement we had in August. To recap, HeatWave is an in-memory accelerator for MySQL database service running in Oracle Cloud. This is a native engine which has been integrated with the MySQL database. So the advantage is that all existing tools and applications, they work as is without any change. Since HeatWave accelerates analytic queries, it accelerates complex queries, and the MySQL database is designed for transaction processing. With the combination of MySQL database in HeatWave, we now have a single database which can accelerate all workloads, whether OLTP or analytics. And unlike in the past, customers don't need to move their data out of MySQL database into some other database for getting good performance for analytics. Right? So it's a single database which accelerates all your workloads. And HeatWave scales to thousands of cores. So the advantage of this is that one of the characteristics of analytic workloads is that they are usually pretty large in terms of data volume. And as your data, which you need to analyze, scales, the advantage is that HeatWave will scale up very well on a large number of cores. And we talked about some of this in the previous presentation. Since HeatWave is an accelerator, the expectation is that it'll be really fast. So the question is, how fast is it? So I'll show you a couple of comparisons. This first comparison is with Aurora. Aurora is Amazon's enhanced version of MySQL. So they took the open source version of MySQL, enhanced it with a bunch of offerings from their end, and they provided as a managed service called Aurora. For 4 terabyte workload for analytic queries, HeatWave is 1,400 times faster than Aurora at half the cost. So if you look at the price performance, HeatWave is 2,800 times better price performance than Aurora. And to give you a sense as to how much faster 1,400 means is that if you take a typical query in TPCH, 4 terabytes, on an average, after creating all the indexes, after optimizing Aurora as best as you can, the query will take about 2.5 hours to execute. With HeatWave, without the need for any indexes, it takes about 6.3 seconds. So 2.5 hours with indexes, 6.3 seconds without any indexes. Right? That's how fast HeatWave is. Now, Aurora is a comparison because it's like, as I said, Amazon's version of MySQL, which has been enhanced, right? So kind of general purpose database. But most of the customers who want to run analytic workloads with MySQL don't really use Aurora. What they do is they move the data into a specialized database for analytics and run analytics there. Now, there are downsides of moving to a different database because now you are stuck with 2 different databases, one for transaction processing and one for analytics. But let's assume that customers are willing to do that. They are willing to take this overhead, the complexity, the cost of going to a second specialized database. What is the performance of MySQL HeatWave compared to this specialized database? So the first comparison is with Redshift, very popular one. With Redshift, what we find is that MySQL HeatWave. So MySQL HeatWave can do both transactional processing and analytics. But just looking at the analytics component, HeatWave is about 7 times faster at half the cost. Now with Redshift, you can only do one thing, which is analytics, right? So a general purpose database, which is MySQL HeatWave, is 14 times better price performance compared to Redshift, which is specialized only for analytics. And there's a lot of aspects with respect to the ease of use. Like in Redshift, you have all these shapes and configurations which you need to choose from. With HeatWave, that is not the case. There is only one shape we offer. And with Autopilot, which we talked about, it's completely automated, machine learning based automation. So it's much, much easier to use. Much easier to use, much faster, much cheaper. All existing tools and applications which are compatible with MySQL work as is. So it's a very, very hard value proposition of HeatWave to compete against. So this is comparing HeatWave with Redshift. Now let's do the comparison of HeatWave with Snowflake. It gets even better. HeatWave is 7 times faster than Snowflake at 1/5 the cost. So same performance advantage as we saw with Redshift, but the price advantage of Snowflake grew even larger. So 35 times better price performance compared to Snowflake. And by the way, this is not any subset of queries which we have chosen, queries where HeatWave does better. This is a standard, industry standard TPCH benchmark. And these are queries which have been derived from this TPCH benchmark, right, on 10 terabytes. As the size of the data grows, the performance advantage of HeatWave over Snowflake over Redshift will only increase. So 13 times better price performance from Redshift and 35 times better price performance compared to Snowflake. Now you can try to have a different configuration of Snowflake. For instance, instead of extra large, you can use a large shape and the cost differential will decrease, but the performance differential will increase. So all in all, the 35x price performance advantage of HeatWave over Snowflake will hold. Ever since we announced this service back in December, there are a lot of customers who have gone live, who have gone production with HeatWave, and I'm listing some of them. The common theme you will see across all these customers is all of them report that they save significant amount of money as they have migrated to MySQL HeatWave. A majority of the customers are from AWS, but we have customers from like a lot of other databases as well. We have migrations from SAP HANA. We have migrations from Teradata. We have migrations from Redshift, right? So a lot of migrations. But one of the common things across the board is people find HeatWave to be much cheaper, much faster. And for those who are running MySQL compatible applications, there is no change which needs to be made in the application. So it makes the use of HeatWave very seamless for customers, right? And that's why you can see Tetris, Red3i, Fancom, Tamara, all of them went production. And this is the common theme across all these customers. Now, while we are very happy that we have a lot of customers who have migrated and are using MySQL HeatWave, we are also always looking for feedback as to what can we do to make it better. So we got feedback, like a bunch of feedback. I guess the last 3 points have been covered in the previous webinars. And the focus today is on the first 2 points, which is how can customers see more SQL constructs be accelerated with HeatWave? And how can they get even better performance for mixed workloads? The feedback or in terms of improvement or managing large data sizes, we talked about earlier that we can now process up to 32 terabytes of data with HeatWave. For automation, we talked about Autopilot. So today, in this talk, you're going to focus about the first 2 things. So let me explain a little bit about what do we mean by mixed workloads. Most of the times, when customers are running their applications, they will have some transactions, like which we call OLTP, but they will also have queries associated, right? So if you're inserting some data into a database, you're inserting this data because you want to get some information out of it, and you will run some queries. When you have queries, like these could be queries which are very simple queries, which are called point queries, like like needle in a haystack, or you could have queries which are processing or scanning over many rows. Mixed workloads are those workloads which have a combination of transactional processing and some decision-making queries. So it's a combination of OLTP plus you can say OLAP, but it can also be lightweight OLAP. Whereas with analytics, you typically refer to typical long-running queries which are scanning all the data, which involve complex joins, which involve a lot of group bys, window functions and such. Whereas mixed workloads need not have the complexity of analytics, but still many of the queries in mixed workloads take a long time in existing products. And we got a lot of feedback from customers that it will be great if HeatWave can attend to those. So what we're going to do today is talk in depth about what is it specific we have done to attend to these two classes of feedback. So the first thing is that we have added a lot of new SQL constructs in the last few months. As a result, there are two things which happen. The first one is that for analytic workloads, we are now able to offload all the 93 TPC-DS queries which are supported by MySQL. So in the past, we have talked about TPCH workloads, and that's something we have been supporting from the time we went GA. But all the TPC-DS queries would work with MySQL, but not all of them were offloaded or accelerated by HeatWave. This is something which we have now addressed. All the TPC-DS queries, which are supported by MySQL, are now accelerated by HeatWave. And these are the list of functions or the SQL constructs which we have supported, and I will talk in detail on each of them. But the net result is that a workload like TPC-DS, which is very representative of what customers want to do, is now accelerated by HeatWave. The second thing is that we have also now paid attention to the kind of constructs people have in their OLTP or mixed workloads, and we have addressed them as well. So a good example is that if you have an analytic-only workload, you don't have insert constructs, or customers don't have, say, create table as select. But in mixed workloads, that is the case, and people wanted to benefit from HeatWave for these. So we have added support for offloading the select part of insert into select construct or create table as select construct. Similarly, text data type, very popular with our customers of MySQL, and that's again something which we are now accelerating. So now let's kind of go over and talk about what we have done for each of these in a little more detail. Window functions is a construct which is very popular with database customers. It was recently added to MySQL. It was added in MySQL 8.0, but it's been supported in many other databases for a long time. So one of the interesting things is when HeatWave went GA in December, we got a lot of requests for window functions. And that was a good indicator that we are seeing migrations to HeatWave, not just from MySQL customers, but customers who are currently using other databases, because window functions are very recently introduced in MySQL. So chances are that majority of the requests we are getting are from other customers as well. So this is a very encouraging sign. And for those who may not be very familiar with window functions, it's an aggregation or a scalar function over a window of input values. So as shown in a couple of examples on the right-hand side, you could have an over clause, or you could have a window clause, right? So what this is doing is it's doing an aggregation over a window, right, of input values. 15 are the 99 TPC-DS queries contain a window function. So clearly it's representative of a lot of analytic workloads. So we now have support for that in HeatWave. Not only do we have support for window functions in HeatWave, we have a very highly optimized implementation of window functions for HeatWave. So window functions can get to be very expensive because if the amount of data is very large, many of the techniques out there, when they do window functions, they resort to global sorting, which is very expensive in terms of the computation time. What we do in HeatWave is we leverage the massively partitioned architecture of HeatWave to do processing for window functions. So we take the data, we partition it across the various nodes, and then within each node across each core of a VM. And then once the data is partitioned across all the cores, we do local sorting on each core, right? And then the window function computation is done for each tuple on each core. And this is one of the very interesting ways. And then you use a very state-of-the-art algorithm. So if you see, at most of the algorithm implementations out there, their average complexity of computation is order of n log n. In the worst case is order of n square. For us, we have been able to reduce it to order of n in the average case and order of n log n for the worst case. So this results in a significant improvement for those customers who will be using window functions in other databases. And when they come and try with HeatWave, they will find that's very efficient. So not only do we have support for window functions now in HeatWave, but we have a very efficient implementation. The next construct which we are supporting, which is again a very popular one, is scalar subqueries. Scalar subqueries are a class of subqueries which return just one row. Right? So as shown in this example on the right-hand side, which is one of the TPCH queries, there is this query, and then there is a subquery, but this subquery is returning one row. That's what a scalar subquery is. Many of the TPCH workloads have scalar subqueries, so do TPCDS. And this is a construct which we now support. And this is a very good example of something where the MySQL optimizer has been enhanced to support it. Right? So we have done a bunch of innovations in HeatWave, but we don't always get a chance to talk about the innovations which are happening in the MySQL optimizer as well. Right? So this is an example of a construct which is now supported. It's unnested, and all of this optimization enhancement is done in the MySQL optimizer, and it's now available in the MySQL database service. So again, a popular construct which appears in many customer workloads as well as benchmarks. The third construct is support for union, union all, and rollup. So I don't need to get into the details of this because this is a pretty commonly used operator, and it occurs in like a lot of queries, both in TPCH and TPCDS. And this is now something which we not only support in MySQL, which we have been doing for the longest time, but we support in HeatWave, meaning that queries which have these constructs, union, union all, and rollup, can be offloaded to HeatWave and then get accelerated. The next SQL construct I want to talk about is limit and offset. Now, limit and offset occurs in a variety of queries, right? So when you're doing an order by, that's also like a top K kind of a query. So I want to walk through this example as to what is the kind of optimizations which we do in HeatWave, and why do customers really want to offload these constructs onto HeatWave? Well, when the query comes in to the MySQL optimizer determines that this is something which can be executed in HeatWave, and the query along with the data is sent to HeatWave. Right? So the data is already present in HeatWave in memory format. The query is sent. When the query is processed by HeatWave, there are a number of optimizations which kick in. So the first thing, for instance, which kicks in is that, like, for instance, take the case of the example 1 or example 2, right? That there is a scan which we are doing, and we want to limit the number of rows which are being returned. So if I'm doing an order by, and if I want to limit the number of rows which are being returned, instead of executing this algorithm completely, the algorithm terminates after this limit has been reached. So if I'm just interested in the top 5 rows, it doesn't make sense for the system to compute the top 100. Right? So the system just terminates the execution after I have reached the limit of the number of rows which need to be returned. That's the first optimization. The second thing which we do, and that's kind of illustrated in the example between 2 and 3, is that depending upon the number of rows which need to be scanned, right? That if and the number of rows which need to be returned, a choice of a different algorithm is made. So if I'm going to be scanning the entire area set, which for instance has 100 million rows, I'm much better off doing a full sort. Whereas if the number of rows being returned is smaller, then I could use a different implementation. So this is the kind of choice we make during the execution of these operations inside HeatWave, that based on the data set, based on the specific predicates and the values of the predicates, we determine dynamically which is the most efficient implementation to execute. And this is all done dynamically in a cost-based manner. So these are all now constructs which are supported in HeatWave. Now, I won't go through the rest of the things, but one of the very other common constructs which people want to offload are like datetime and string cast functions. So what may happen is that you have an app, so you have a query. There may be some complex or costly components of the query, but if in the past, if you had any of these constructs, the query would not get offloaded, right? So one of the things to understand about the MySQL and HeatWave architecture is that when a query comes into the MySQL engine, if all the constructs can be offloaded, only then is the query sent to the HeatWave engine. Otherwise, the query is executed by the MySQL optimizer or the MySQL database. So that's why it's very important for us to look at all the constructs which customers want to accelerate so that the entire query can be pushed to HeatWave. And that's when you get the massive scalability and the massive performance. So this is like a list of the various functions which we are now supporting on HeatWave. Okay, so far this was on the analytics side. Now let's come to some of the requirements, the requests which we got for mixed workloads. So one of the very common things which customers do in mixed workloads is that they have a construct like insert into select or create table as select. So what this is doing is that in the case of say create table as select, that's creating a table which is the result of the rows which are being returned from a query, right? And so take the case of example 2. So there's this query, select star from orders with some predicate. The rows which are being returned from this are the ones which are being created, right? And there's a table being created for this. Now, the request has been that can we offload the select part of the query to HeatWave? Because please bear in mind, HeatWave is an in-memory engine, but it does not do any DMLs, it does not do any DDLs. All of that is done by the MySQL database by InnoDB. So what we are now able to do is that when the query comes in, or when such a construct comes in to the MySQL optimizer, the select portion of the query is sent to HeatWave, it's processed, and the DML or the DDL, so the insertion into small orders or creation of the table, that's done by the MySQL database. This thing works extremely efficiently because if the select portion of the statement is the more expensive one, then the customers will see a dramatic improvement in performance, right? So we have seen that in general, HeatWave is maybe say 1,000 to 5,000 times faster for many of the complex queries compared to the MySQL database. So if in these statements, the bulk of the timing is being spent in the execution of the select statement, customers will see a dramatic improvement in their performance for such statements. However, if the majority of the time is being spent in the insert part of it or in the create part of the statement, then customers will not see as much of a benefit, right? Because the processing of select is being done in HeatWave, the rows are returned to the MySQL database, and the insertion or the creation is done by the MySQL database. So if you have a large volume or a very large number of rows which need to be inserted or created, then the performance advantage will not be as much. But in a very large percentage of the cases, customers are doing some kind of a reporting, they're doing some kind of an aggregate, and then they want to insert that into a table or to create a new table. For those, there is a dramatic improvement in performance. It was a very, very sought after, commonly asked request for mixed workloads, and I'm glad to inform you all that it is now something which is offloaded. The second very popular thing has been the support for text data type. So we have had support for the varchar data type for a while now, but many times customers prefer to use the text data type. And the main reason is that when customers are using varchar, they have to bound it. They have to specify what the limit is or the size is, or like what the upper bound is. In the case of text, it is like much more of a freelance where customers don't need to specify like what is the upper bound, right? As shown in the example over here. We are now able to offload queries which have the text data type support. Now, what this does is that a whole bunch of like new classes of like operations like like is one of them, or upper or substring or one of these regular expressions, these can now be evaluated and accelerated by HeatWave. So that's a very big deal. The thing, however, please to note is that we do have some limitations, for instance, on the maximum character limit. And it's the same limit both for varchar as well as for text. So we do now support offloads of queries which involve operations on the text column. And this will enable a very large class of applications which earlier were not accelerated because they were using text. Right? The kind of operations we are supporting are regular expression, upper, substring, like, regular, greater than or less than. Okay, so this is, so far I talked about what are examples of new constructs we have supported in the last few months over and beyond what we already did in version 1. As a result of that, we can now accelerate the entire TPCDS workload. We can also accelerate a lot of mixed workloads. Now I want to talk about what else have we done to facilitate mixed workloads. So in the first webinar series, I talked about MySQL Autopilot. MySQL Autopilot provides machine learning based automation for various aspects of the MySQL HeatWave service. So for instance, it provides automation for system setup, for loading of data, for query execution, and for failure handling. And there are 9 features which we support. Everything which is shown in the upper half, which is during system setup and data load, is exposed via an advisor, where the system using machine learning makes a recommendation, but it's really the user, the end user, who has to abide or follow that recommendation. So it's optional. The user can decide not to do it in some cases. Everything which is shown in the lower half is completely automated, that the system makes a determination and it follows on that determination, and there is no way for the user not to follow that recommendation, right? So it's all automated. So one of the things which you have done specifically for the mixed workloads is the first one shown in the query execution, which is auto scheduling. So let me talk about that in a little more detail. Now, as I said, mixed workloads are those workloads which have a combination of transactional processing as well as queries, or decision making, as you may call it. OLTP constructs or OLTP queries are typically very, very short running. Whereas if you have queries which are little more complex, they're going to take longer. If you look at most of the systems out there, most of the database schedulers out there, they have a FIFO way of execution, meaning that the queries get executed in the same order in which they came in. So if you have, say, queries 1 through 20, and they're sent in the order of query 1 followed by query 2 followed through query 20, those will get executed in that order. Well, that doesn't always work well, because let's assume your query 1 is the longest running query. It's going to take an hour, whereas rest of the queries are just going to take a minute each. The system is now stuck. It has to now execute for this query number 1. It'll take 1 hour, and then the other queries are going to get executed. Well, that's not a very good user experience, because the shorter running interactive queries is where the customer would like a better response time. So what we have done, which is fairly unique in HeatWave, is that for every query which comes in, prior to execution, we predict the execution time of the query. Once we have done this prediction, we then prioritize those queries which are going to take less time to execute. The advantage of this is that the wait time for the short running queries, which are the interactive queries, reduces without causing a significant increase in the time for the long running queries, right? So in the example I was giving, like 1 hour versus 1 minute each. Sure, I mean, it's okay if all these queries which were taking 1 minute each were to execute earlier, because they may add up 19 more minutes to one query, and that's not too bad. But otherwise, in the first in, first out order, all the 19 queries are taking a hit or are having to wait for the first query, which in this example took 1 hour. So there are a lot of advantages of this approach, where the system using machine learning became intelligent, predicts the time it's going to take for each query to run, and then schedules them so that the shorter running queries are executed prior to the longer running queries. And the example over here shown below is our queries from TPCH. And you can see that we have a significant improvement in the elapsed time for the shorter running queries and a small degradation in the total running time for the longer running queries. So please note that the execution time itself does not change with this approach. It's the wait time which has improved and which improves the overall experience for the user. All of these constructs I talked about, all of these new queries which are now enabled as a result of the new offloads I talked about, are as scalable. They perform as well on HeatWave as the earlier queries did. So what this is showing is over 60 different servers, each server having multiple cores, right, and 32 terabytes of data. End-to-end queries are able to scale with a scale factor of close to like 0.9. So what that shows is that the end-to-end scalability of the system has either remained the same or actually gone up as we have supported these new constructs. So what that tells you is that all of these new offloads which we have done, we have designed and implemented them very efficiently. Okay, so I talked about the mixed workloads, saying as to how we are supporting these constructs. The question is that, okay, how well do we do compared to, say, other vendors? Well, instead of coming up with our own benchmark, where we always have the risk that we may skew it, to our advantage, we decided to take an industry standard benchmark. And this is a benchmark called the CH benchmark, which is from TU Munich, Technical University of Munich. And what this benchmark does is that it combines the industry standard TPCC and TPCH benchmarks. So it keeps all the TPCC statements as is, but it modifies some of the TPCH queries to use the new schema. So all the TPCC schema and statements are as is. The TPCH queries and schemas have been modified. And this benchmark measures both the throughput as well as the latency for the OLTP statements as well as the OLAP statements. Now, the other interesting thing about mixed workloads is that most of the time the data sets are much smaller. So in analytics, people are usually operating on terabytes of data. For mixed workloads, that may not be the case. So typically we see that customers are in the range of hundreds to hundreds of gigabytes. And I've shown you numbers which demonstrate that on larger data sizes, HeatWave really outperforms all the competitive database services, both in performance as well as price performance. So what we decided to do was to show that for our customers, that how would the performance of HeatWave compare with Aurora for a much, much smaller data size, right? Because like we showed that, okay, early on, that for 4 terabytes, it's 1400 times faster. Now let's try for the other extreme, much smaller database, 100 gigabytes. Even on 100 gigabytes, if you take the OLAP portion of this mixed workload, we find that HeatWave is 18 times faster, has 110 times the throughput, meaning 110 times the number of transactions compared to Aurora at 42% of the cost. Much faster, much higher throughput, much lower cost than Aurora. Now let's look at the second part of the benchmark, right? The second part of the benchmark is only transactional processing, right? Like no OLAP queries at all. Same data size, 100 gigs, right? And we took 128 concurrent sessions. We find that the latency is at par with Aurora. Throughput is at par with Aurora. However, the cost is significantly cheaper with Aurora. Again, it's 42% of the cost, meaning less than half the cost of Aurora. So the reason this result is very interesting is what this is showing us, regardless of the kind of queries or workloads you may have, you're always going to save money as you migrate from Aurora to MySQL HeatWave. The performance improvement, and for all the workloads you have, for all queries, all statements, your performance will be same or better or much, much better with HeatWave. So if it's only OLTP, your performance remains at par with Aurora. If you have small workloads but little complex queries, then you're going to be about 20 to 100 times faster than Aurora with HeatWave. And if you have larger data sizes or more complex queries, then you're going to be much, much faster, like 1400 times faster compared to Aurora. But the thing which always remains constant is the much lower cost. So what this now does is that it makes HeatWave a very attractive proposition for all your workloads. When we went to GA in December, we had talked about how HeatWave is an in-memory accelerator for analytics. Now, what we can say is a HeatWave is an in-memory accelerator for all your workloads, and accelerator as well as it reduces the cost. What I want to walk you through are now some examples of customers who have migrated, and I will just talk about the ones who have migrated from Aurora to HeatWave to see what is their experience and feedback compared to the benchmarks, because I'm showing you the benchmarks, right? But I also want to give you a sense of what have the customers said about the experience. So the first one is Red3i. They migrated about 6 terabytes of data from Aurora to the MySQL database service. When they turned on HeatWave, they found that some of the queries improved by 1,000 times. So the engineers themselves said, hey, queries which were taking hours are now taking seconds, right? For some queries. Now, aggregate, though, which is a combination of long-running, short-running queries, DMLs aggregate, 85% improvement in the overall workload, which is like 6x, more than 6x improvement in the overall workload. And they saved 60% by migrating from Aurora to HeatWave. So much faster, much cheaper. And the reason it was very, very easy is there was no change to the application, because Aurora is API compatible with MySQL, so they could just migrate the application to HeatWave. So very successful migration. The second example is Tetris, based out of like South America. Very similar experience. Now, in this case, the customer again had what they thought was an OLTP transaction, but OLTP application. But typically, when you look into it, you always have a combination of transaction processing and queries. And they found again, in this case, that the performance improved from minutes to milliseconds. So orders of magnitude improvement in performance. Migration was seamless, like very little change to the application. And their cost dropped by more than half as they migrated from Aurora to HeatWave. Fan Communications, very similar story. No change to the application for migrating from Aurora to HeatWave. Performance of the workload improved by 10 times, and the cost dropped significantly. And the last one I want to talk about over here is like a fintech company called Tamara. Very similar experience. Their cost reduced by 3 times as they migrated from Aurora to HeatWave. Significant acceleration to their workload. And one of the things they reported, and as well as other customers have said, which I should highlight, not only is it the case that their existing applications are getting much faster, what is happening is that since HeatWave is so much faster, they can write more complex applications. They can write more complex queries now, because now they will execute in a reasonable amount of time with HeatWave. So to summarize, what I want to point out is MySQL database service with HeatWave is the only MySQL-based service which provides efficient processing for mixed workloads, analytics, and transaction processing. MySQL HeatWave provides the best price performance for analytics compared to any database service we have benchmarked against. Compared to Snowflake, it's 35 times better. Compared to the latest version of Redshift Aqua, it's 13 times better. It's 36 times better than Google BigQuery. It's 15 times better than Synapse. And in all the cases, it's faster and it's cheaper, right? So if you want better performance, HeatWave is for you. If you want same performance but lower cost, HeatWave is for you, right? So it's like a very, very good fit. Then for mixed workloads, which is much smaller data sizes, like 100 gig data sizes, combination of transaction processing and queries, even there, HeatWave offers much better price performance, 42 times better price performance compared to Aurora. We have added machine learning-based automation in HeatWave called MySQL Autopilot. And with this, MySQL database service becomes the only service to have machine learning based automation. And this is a very sophisticated like automation, which is better than what any other competitive database services have. MySQL database service is the only one which provides hybrid deployment, meaning that customers can have the data on premise. And for the ones they want to run analytics on, the data can be automatically replicated using standard MySQL replication to the cloud on which they can then run analytics. And finally, MySQL database service with HeatWave is the only service, only MySQL-based service, which is offered, managed, and supported by MySQL development. So the advantage is you're always on the latest version. You're always getting the latest patches with their security, functionality, performance. I would encourage all of you to test drive MySQL HeatWave for free today. You can go to this website and get information as to how you can get free credits to try this thing for yourself. We encourage you to join us in social media on Twitter, Facebook, LinkedIn. And if you would like more details, and we have a lot of details like blogs, white papers, instructions for the benchmarks. So all the benchmarks I have showed today, all of them are available on GitHub. So users can go download the scripts themselves from GitHub and try it for themselves. Right? So all the details of that are available on oracle.com/HeatWave. So thank you for your time and happy to take any questions.